Okay, so we do, what section is this? 3.6?
3.7.
7. Thank you. 3.7. So 3.7. It's about, let me write down this way. Derivative of inverse function. Okay. So let me write down the definition of inverse function first. So given function f with where s? Yes. Where's the I put the s? No s there. Yeah, it's same thing, isn't it?
There's an S in inverse.
There's no s.
You're fine.
Domain C and range R. It's an inverse function. If it exists. It's the function. We denote like this, right? So this is not the negative power. We know that. If we have function notation with the -1 means it's inverse function, okay? With domain R and range D. Okay, this means if we have a function, if we have an inverse function, then they swap. So domain of f will be range of inverse function. If we have range of f, then that will be domain of inverse function, right? Okay, so basically we have xy order pair, they will change the yx. This one is a little bit weird notation. Maybe how about this? AB, okay? A for the first coordinate, which is x coordinate. B for the y coordinate, which is second coordinate, right? Then inverse function, then we change it to BA, all right? That's why their domain and range swap, okay? All right. Such that so inverse of y equal to x if f of x equal to y. Okay, we know the notation that is inverse. Okay, so inverse each other when you say that. Then we know the definition. How do we check? We check this way. If f of inverse of y equal to y, normally we get the x. Let me write down this notation because we check this way all the time, okay? And inverse, like that, right? Just how we check. How we check, like inverse each other, then f of inverse of x equal to x, one more parentheses, and then we have inverse of I knew it. Inverse of f of x equal to x. That's how we check, right? All right, so then when I'm teaching the algebra course, how I explain inverse, okay? So how do you wear your clothes? Like you have had shirt, pants, and socks, shoes. Which one you wearing? Tell me.
All.
Yeah, so make it in order, okay? You're not wearing it one time. Can you make order? Which one first when you wear?
Socks, maybe.
Socks first, then which one?
Maybe pants.
Pants, then
Shirt.
shirts,
We'll say shoes,
shoes.
and then hat.
Okay, then this is the f function. Then we do inverse. We do undid, right? So whatever we did, we do undid. We do. Let me write that. F did. Then this is undid. So hat, then shoes, then shirt, then pants, then socks. Okay, so I'm teaching this way. So undid, what will you do? What you did. All right, so then like a picture, we have f here, then this is x. We map, we give it to the function like this. Let me write down this way. This is a y. Okay. We have function f, send it to that, right? Then inverse, reverse, right? So we do like this. So inverse of that. Okay. Now, if we call the domain of f in here, this is the range of f. Okay, and then I just said earlier, the x and y swap. That's why domain of f will be range of inverse, right? So here, domain of f. So this will be range of inverse function. Then range of f will be domain of inverse function, okay? All right, so, and then inverse function must be one exact x value send it to one exact y value, okay? So that is one-to-one function must be, so let me write down. A function, yes, exactly 1/4 for each input. Okay, let me erase All right. So second one, definition. F is one-to-one function. So someone who made in the chat question, let me answer after this lecture because we have a lot to go over today. So one-to-one function. So basically exactly one element from the X, then exactly send it to Y value, right? That is one-to-one. Then how do we check the one-to-one? It's a function. So we check the to be a function, make a vertical line test, right? Then we check the one-to-one function, we do horizontal line test. So must be one point intersect with the line, right? So let me write down the function f is one-to-one. So I introduced this word, right? If, only if. Means that the both direction is make a true statement, okay? Let me read. Okay, so if only if means a function f is one-to-one, then every horizontal line intersects the graph of f no more than once. That is a true statement. Or we can say that every horizontal line intersects the graph of f no more than once, then the function f is one-to-one. Make sense? So this direction is true, or and this and not true, and this direction also true statement. So that is if only if, right? I mentioned it before. If only if. Okay. So for example, we have parabola. We're going to make a horizontal test anywhere in the graph, right? Right here. How many points intersect there? Two, right? So here and there. So this is a function, parabola, which is a quadratic function, but this is not one-to-one, okay? A function, but not one-to-one. Not one-to-one function. So in order to make a one-to-one function, we have to restrict, okay? Either this way or this way. We restrict, then this is a one-to-one function, okay? So any function, maybe other one, x cubed, right? So we have horizontal line test. So we draw anywhere in the graph and then draw the horizontal here. And how many points intersect there? It's a one. So we call this as a one-to-one function as well, okay? All right. Okay, then from algebra and pre-calculus, we practice how to find inverse function, right? So let us do that because in the calculus one, they require you to. Find the inverse for the function f of x equal to 3x minus 4. State the domain and range of the inverse function. Verify the inverse function. So I just omit. So how do we verify the inverse function? There will be f of inverse of f, f of inverse of x equal to x, and we will verify other way too. Okay. All right. So how do we find the inverse from the function? So we say set y equal to 3x minus 4. Step 2, solve for x. Okay, how? How do we solve for x? What do you get? Okay, not yet. So solve for x.
Y plus 4 divided by 3.
Yeah, so y plus 4 divided by 3 equal to x, right? Now swap. So your classmate says swap, right? Exchange x and y. So this will be x plus 4 over 3, right? Then we rewrite this is as y equal to the inverse notation, okay? So inverse will be x over 4 over 3, okay? That's how we find. All right, so look, what's the domain of f? Domain of f?
All real numbers.
All real numbers, right? Okay, it's a straight line. So all real numbers. So this will be range of the inverse function. So this will be all real numbers. Then what is range of the function? Range of a function?
All Also all real numbers?
Yeah, also real numbers. Okay. Then this will be domain of the inverse function. Okay. Now, we need to verify not algebra work. Okay, so verify. Show that is equal to that. Okay. So f of inverse, which is x plus 4 over 3, right? Okay, then we substitute x plus 4 over 3 into the f function. So we have a 3 of x plus 4 over 3 minus 4. Okay, now we simplify, then we get x plus 4 minus 4, which is x, right? Can you see that? So we verify that, okay? And other way, we're gonna show inverse of f of x equal to x. So inverse of f of x, where is it here? 3x minus 4. So inverse of 3x minus 4 means we substitute into the function. So we will have 3 times 3x minus 4. Am I correct? So I got a wrong one. Sorry about that. Hold on. Inverse is there. So inverse is there. So we put in there. So 3x minus 4, then plus 4, right? Over 3. Look, we have 3x over 3 because negative 4 plus 4 is 0, right? Which is x. We verify that too, okay? So I'm not gonna write down in Word because we don't have time, all right? So yeah, we found the inverse function. They are inverse function each other, right? Because we show that in the bottom, all right? Now, graphically, let me show this. Let me erase this one. So inverse function graphically, this is a reflect about the y equal to x. Okay, so for example, if we have the graph like that, right? Then let me use y equal to, okay, y equal to x. So graphing inverse function is a reflect y equal to x each other, vice versa, okay? So this is, I'm gonna draw like that. Like this, okay? If I have like this, okay, then y equal to x, then I can draw this one like this. I should use different color, huh? Okay. So you guys understand? For example, if we have this one, let's say that 3 and 0, then we switch x, a and b, right? The first coordinate, second coordinate, we switch that. So this will be 0 and 3. Okay. This one, if we say that this one is, I don't know, maybe 10 and 2, then this will be 2 and 10. Okay. Make sense? All right, let's move on to trig. Let me erase. Okay, so we have inverse of trig functions. Trigonometric. There is one person picking on my spell, so I'm very be careful. Trigonometric functions. See, he's watching me. Look at him. He's looking at me whether I make a mistake for the spell. All right. So inverse trigonometric function. So look, let me draw the graph roughly. So sine start to 0 like this, right? Okay. Then we just say that in order to be inverse function is supposed to be one-to-one function, right? Then horizontal line test, they fail, right? Then what do you get? We get only this part. Okay, so this part for the only, I did not write down. This is a sine function. Okay, so in this case, this is negative pi over 2. This is pi over 2. Okay, so we're gonna get that only that part. All right, since inverse function we make, then their range is +1 and here is -1. So -1 to +1. So it will be swapped. So their domain x from negative pi over 2 to pi over 2 will be the range of inverse function. And then their range from -1 to 1 will be domain of inverse function of sine. Make sense? Okay. So let me write down this one in Word later on, really quickly. Okay. Just understand that. Okay. Review from the trigonometry, the course. Okay. All right. Here, cosine. Let me draw. So cosine start 1, right? So it should be like this, like that. Okay. So once again, horizontal line test fails. So we take the only this part in order to make an inverse function from the function. Okay. So then, oops, yeah. Then this will be from 0 to how much? This will be pi. Huh? This much is pi. So this will be -1. This is +1. Okay. So from 0 to pi, from the domain, it will be range 0 to pi. And then from -1 to 1, range will be domain for the inverse function. Okay. This is cosine x. Okay. So let me draw the inverse function of sine and cosine. How about one more tangent? Then maybe we explain until tangent, then rest. I'm gonna just say that. Okay. Tangent. Tangent here. Let me use here. Tangent is a tangent which is sine over cosine, right? So there is asymptote because the fraction, right? So when cosine equal to 0, there is asymptote. When this one happened, when negative pi over 2, right? So here asymptote. Okay, then tangent looks like that. Okay, getting close to asymptote here, right? Then I am drawing only the one segment asymptote and then graph, right? There's a bunch of them, right? Then also this one is a fair with a horizontal line test. So we just pick between negative pi over 2 to pi over 2, okay? Then this domain is negative pi over 2 to pi over 2, then will be inverse of the range, right? Then looking at the range is negative infinity to positive infinity, right? Then this will be the domain of the inverse tangent function, okay? So let me draw the inverse one. Not good in this one. This is inverse of a sine. So -1 to 1 and pi over 2 to negative pi over 2. So looks like a cube. Cube. Okay, and then cosine, inverse of cosine. This one will be pi, and this is 0, and -1 to 1. This will be other way cube, like that. Doesn't look good. Look at the picture in the book. And this one inverse of a tangent. Okay, this is positive pi over 2. This is asymptote, negative pi over 2, right? Then we approach to asymptote this way. Okay. All right, so picture is not good. All right, so let me write down in Word everything. Let me erase. I know you guys are writing. Take a picture. Okay. Let me write down definition. Inverse. Y equal to inverse of that. If only if, then this is between negative that and if only if. So I just copy from your book. And then 10 inverse. So this one, what I explained to you about the restriction, right? Because they fail the horizontal line test. So they make that And then cotangent, inverse of cotangent there. Okay. So same concept. And there is in 1.4. Okay. So you might take a look if you want. And cosecant, inverse of cosecant. Then we have Rashi cosecant y equal to x, and y is between negative pi over 2 and pi over 2. Y cannot be equal to 0. Last one, inverse of secant. Then y is between the pi. Y cannot equal to that. Okay. All right. So let's go over. Since you guys writing, I'm not gonna erase this one. All right, let me explain to you this one. All right, so if we have the, if we have the function like this, okay, so we call this f of x, okay. Now, we know how to graph inverse function is reflect about y equal to x, right? So this is inverse function. Let me use a different color. You see? Okay. So let us indicate that is inverse function notation like that. Okay. Now, we want to draw. Okay. Let me put the point here. This is A. This point will be A, and the y coordinate, which is f inverse of A, right? Correct? Okay. Then other point there, then they change that, right? They change an x and y coordinate system, right? So which is this point will be inverse of A and A. Do you agree? Right? That's what I explained to you earlier, right? They swap AB coordinate, right? Then I'm gonna make a tangent line from this point. Okay, this tangent line, and then we make a point here. We want to know about the slope of the tangent line, right? Then it will be rise over run, right? So let's say that rise will be, let me use the same letter variable, P, and run will be Q. So we say that slope, okay? Then how do we indicate the slope of a tangent line? That will be inverse of, at this point, which is A, right? And prime. Okay? Then this will be rise over run, which is P over Q. Okay? Now, let me draw slow tangent line here as well. Oops. Okay, then also rise over run. So slope here. Okay, so in general, think about that. Rise, which is change in y. Over run is change in x. Since inverse each other, let me use Q over P. Make sense? Right? They swap the coordinate system, okay? Then look, the slope in this case, we want to write the f prime of x, right? In general, we write down, right? But in this case, I want to indicate in terms of inverse function notation. So that will be, this way, x will be, look, in f prime of x will be, in this case, inverse of a. Do you agree in this case? At the point, the x is the
Yes.
first coordinate. Okay, good. X is the first coordinate. Then we said x, if we said x, in this case, inverse of f of a, right? Can you see that? It's okay. Okay, now let me erase on the top. Sorry. Okay, now we can create, look. So we want to express inverse. I know, I will, don't worry, okay? So let me write in this one first. I'm rushing, that's why I don't know what to do. So inverse of the derivative of inverse of A, okay? Then we can say that this will be 1 over look, we have a P over Q, so it's the same as 1 over Q over P. Is it correct? Same as? Which is P over Q, right? Can you see that? It's the same as. Yeah, we can express this way, correct? Yes or no? Okay, silent means yes. Okay, good. So then we can express this one. So that is Q over P Whew. One more thing. Like that. Okay. You guys make me so laugh. So we can express this way, okay? So we derive the formula of okay, let me oops, I didn't erase completely. Thank you. So graphically, I showed you this one. Okay, now algebraically, I'm gonna show you. All right, so let me erase this one. So let us say that if we have, oops,
Oh, you erased the other parts with it too, like the red part with the black.
sorry, maybe later, okay?
Okay.
Yeah, so let me show you later, okay? Please wait. Okay, we want to derivative both the side, okay? So we derivative. Okay, then we derivative of x, what do you get? One, good. We get one. We derivative f of f inverse of x function. What do you get? So we're gonna use a chain rule, right? So f prime of inverse of that and inverse of prime, right? So I'm using your notation. All right. Then we do solve for inverse of prime of x. Okay, so that is the here, the right side. And divide by everything, right? So 1 over f prime of inverse of x, right? So this is that, okay? Now, one more alternatively, I don't know why your book gives us this formula as well. Maybe the author, the writer, did not like this notation. Alternatively, if y equal to g of x is inverse of f, then g prime of x, which is 1 over okay, look, you guys so busy with the writing. Looking at this formula, we want to find the inverse of prime of x. So that is a derivative of inverse of a function, right? Then looking at this one, 1 over the f prime of inverse of a function inside, right? So here is the same, but we should know g of x is the inverse of the f, right? So f prime of inverse is inside. This means, okay? All right, so you can remember top one, you can remember bottom one. Just remember the concept, then easily to remember, okay? Let me erase. All right, so let us do is the inverse function. Theorem. So let me just write down. Find the derivative. Let me see. Find the inverse function. X plus 2 over x. Okay. Then find the derivative. G prime over x. How about that? Make it short. Okay. All right. So what's the f in this case? So let y equal to x plus 2 over x. Then solve for x, right? How do we do? Times x. So we get xy equal to x plus 2. And xy minus x equal to 2. Then x, y minus 1 equal to 2. So x equal to 2 over y minus 1, right? Then exchange x and y. So we have y equal to 2 over x minus 1. Then we rewrite inverse notation. Okay, so inverse of that. Oh, wait a minute. We don't use that, huh? Because they are using g over x. Okay, but let's say that f of x, that's fine too, because we use the example start g over x. So let me write down f of x. How about that? In general, we write down that. Because I don't want to get confused. If we are using inverse notation, then we have inverse of prime of x, then 1 over f prime of inverse of x, right? But then if we are using as a g of x notation, then we're gonna find the g prime of x, which is 1 over f prime of g of x, okay? That's why I'm using f instead of inverse notation, all right? All right, so we found the inverse of g. Now we're gonna find g prime of x. Now, before we do that, let us find f prime of x first, right? What do you get? F prime of x?
Are we doing that for the f of x equals 2 over x minus 1, or are we doing that
That's
for
correct.
the original function?
This one.
This one, okay.
Mhm. How do you find f prime of x?
The quotient rule.
Quotient rule, good. Quotient rule. So let's see. F over g, which is f prime g minus f g prime over g squared. So f prime, which is 0. So first term is 0 minus f, which is 2g prime. What do you get?
Just 1.
G prime is 1 over g squared, which is x minus 1 squared, right? All right. So let's take a look. F prime of g of x. Okay. This means, okay, let us do one step, 1 over. Let us do that, one step. So g prime of x equal to 1 over f prime of g of x. That is 1 over f prime of g of x, where's g of x? X plus 2 over x, right? Now, can you see that? What to do, right? X plus 2 over x, we substitute into f prime of x, okay? So that is 1 over negative 2 over x, in this case, x plus 2 over x minus 1 quantity squared. All right, then we do algebra, right? So this will be 1 over negative 2 over x plus 2 minus x over x, right? Squared. That is 0. So 2 over x squared. So let's see. That is x squared over 2 squared. Now we have a negative 2 there. Then we get x squared over 2 with a negative, right? Okay, this is the final answer. It's okay? All right, then let us do inverse of a trigonometry function. Okay, let me erase this one. Okay. Find inverse. We know that inverse function already, right? So sine, inverse of sine. So find the derivative. How about that? Find derivative of g of x equal to inverse of x. Okay? All right, then we know that f of x, which is sine x, right? Okay, now, how about this? G prime over x, then we have 1 over f prime of g over x, okay? So instead of inverse notation, we are using that. And what's the inverse of this? I'm sorry, what's the derivative of f? Derivative of f, what I get?
Cosine x.
Cosine x, right? All right, then look, it's 1 over f prime of g over x, which is inverse of sine x, okay? Then f prime, which is 1 over cosine x. So we plug in inverse of sine x, right? It's okay. All right, then look. Let's see. We have let theta equal to inverse sine x. Okay. Then sine theta, it's the x. Okay. Then sine theta in terms of the what is called the triangle identity. So opposite side over hypotenuse. Right? Look, x means x over 1, right? So in terms of angle theta, it's a right triangle. And then angle theta there. Then I'm standing here in angle theta. Where is the opposite side? It's here, right? Okay, now where's the hypotenuse, which is the longest one, right? Then by Pythagorean identity, we can express the adjacent side. This is adjacent side, which is 1 minus x squared. Do you agree? Okay, because the square root plus minus, right? But we take the only length positive. Make sense? Okay, then look, we have okay, so cosine inverse of sine x. Okay, and since cosine theta, since we said that theta equal to inverse of sine x, right? Okay, then cosine theta, which is adjacent side over hypotenuse. Let me denote it like h, right? Then adjacent side, which is square root 1 minus x squared over hypotenuse, which is 1. That is the same as that. Okay. Now, we done. So it will be, I'm going there. Okay. 1 over square root 1 minus x squared. Okay. Because of this one. Because the formula said that 1 over f prime of g over x, right? So we plug it. So we derive what's the inverse function of derivative sine function, okay? All right, then let me write down all the trick the formula, okay? Let me erase. So theorem 3.13, derivative of inverse trigonometric functions. Okay, so inverse of sine. Okay, normally your book indicated that like this. Okay, but then we always have using chain rule for the derivative. So let me denote this way. Okay, so you guys said that you want g over x, right? Then I'm gonna make this way. 1 minus g over x squared and then g prime over x. Okay, I'm gonna make it this way. All right. And inverse of cosine g over x. Then we have -1 over square root 1 minus g over x squared and g prime over x, right? So let me write down. Then we have a tangent, inverse of a tangent, g over x, which is 1 plus g over x squared, then g prime over x, okay? Then cotangent over inverse, g over x. Then this will be g prime over x, and then 1 plus g over x squared, and secant inverse g over x, which is g prime over x over absolute value of g over x and square root of g over x square minus 1. And the last one, inverse of cosecant, okay? Then negative g prime over x on the top, and then g over x, and then square root g over x squared minus 1, okay? Whew. All right, so let us do one problem here. Find the derivative of f of x equal to arctangent. We read arctangent as well, right? And x squared, okay? Look, they never give us x because x is a very default, basic, right? Always using chain rule, okay? All right, then we're gonna use the formula. So this will be f prime of x, which is equal to 1 plus g over x squared, okay? So cotangent, yes, thank you. And 1 plus g over x, which is, we are using inside the parentheses, squared, okay? That means x squared inside the parentheses, and then we have another square from the formula. Can you see that? And then we do derivative of x squared using chain rule, right? Now, 1 plus x to the 4th power. Now, with derivative x squared, what do you get?
2x.
2x, okay? This is the answer. All right, how about, let me erase a little bit. Yes, I told you in the beginning, we're gonna have a little bit more today because review for the inverse. We should understand what's the inverse function first, right? All right, so if we have find the derivative, second one, how about this? What do you do? Number one. Derivative. How do we find the derivative of the function? Derivative. Hello. How? We derivative of the function. We have to recognize how do we do? Product rule, good. Product rule, okay. So we do f g, which is f prime g plus f g prime, okay. So here, f prime, what do you get? F prime is 2x, then g, which is inverse of a sine function, then plus f, which is x squared. What is the g prime? So inverse of a sine function, which is, we can just using that 1 over, the original is 1 minus x squared, right? That's it. Okay, so let us do one more problem, like similar, very similar with your homework. So example 3. I wanted to do application, but we don't have time, so k over x, 7 arc tangent, 8, I think sine 2x. Okay, I think this is. Okay, all right, so we do derivative. This is the last one. We derivative. What we have to do first? Inverse of a tangent? Inverse of tangent. This is general, okay? This is a composite function. Product rule, only the multiplication of two functions or more than two, right? But this is one function with a composite function. Can you see that? Okay, we have to recognize. So we're gonna use the inverse of tangent first. So 7, inverse of tangent, 7. Then over 1 plus g of x square means everything inside the parentheses squared, right? Squared. Okay, now we do derivative. What is inside, right? Okay, then what's the derivative of 8 sine 2x? So I simplify the denominator, sine squared 2x, right? Okay, and 64, a squared. All right, so what's the derivative of 8 sine 2x? Hurry up so we can go home. 1, 2, 3, time's up. So what is a sine, derivative of a sine? Cosine, good. It's a cosine, so 8 cosine 2x, right? Then we do derivative 2x. Okay, that's it, done. So can you please calculate 7 times 8 times 2? Seven times 8 times 2? 1 and 12, yes. Thank you. This is the final answer. A lot of work today. Okay, let me erase. 1, 2, 3.